It's thrilling to be able to see something that's never been seen before. This emission that we're seeing is thermal emission. Even on the night side, the surface of Venus is so hot that it's glowing faintly at very red wavelengths. These whisper images are really exciting because they provide a new window into the lower atmosphere and surface region of Venus, where these extreme conditions exist. Venus, often called Earth's twin due to its similar size and composition, is one of the most mysterious planets in our solar system. Its thick, toxic atmosphere, crushing surface pressure, and extreme temperatures have made it an inhospitable yet intriguing neighbor. Over the years, various space missions have attempted to pierce the dense veil of Venus's clouds and capture images of its surface. These real images, though few and challenging to obtain, have provided a fascinating glimpse into what we actually saw there, revealing an alien landscape unlike anything on Earth. Venus has been a source of human fascination for centuries, capturing the imagination of civilizations across the globe. Known as the morning star or evening star, Venus is the brightest object in our night sky after the moon. Its brilliance and regular patterns in the sky inspired countless myths and stories, and it was often associated with love and beauty in ancient cultures. Despite its alluring appearance, Venus remained a mystery for millennia. However, the dawn of the space age in the 20th century gave humanity the tools to begin uncovering its secrets, starting with the Soviet Union's ambitious Venera program in the 1960s. Venus is often called Earth's sister planet due to its similar size, mass, and proximity to the Sun. However, any resemblance ends there. Venus is a hellish world with surface conditions that are extraordinarily hostile to life as we know it. Its dense atmosphere, composed primarily of carbon dioxide, creates a runaway greenhouse effect that traps heat and drives surface temperatures to over 450 degrees Celsius, 850 degrees Fahrenheit, hot enough to melt lead. Adding to its inhospitable environment are thick clouds of sulfuric acid that perpetually shroud the planet, reflecting nearly all sunlight and making optical imaging from space nearly impossible. These harsh conditions posed significant challenges to early attempts to study the planet up close. The first successful flyby of Venus occurred on December 14, 1962, when NASA's Mariner 2 spacecraft conducted a brief but groundbreaking study. Although it did not capture images of Venus's surface, Mariner 2 provided humanity's first direct data from another planet. It confirmed the extreme temperatures of Venus, measured its thick atmosphere, and detected no significant magnetic field. This was a pivotal moment in planetary science, as it validated the feasibility of interplanetary exploration and laid the groundwork for future missions. The Soviet Union soon followed with the Venera program, the first series of missions designed specifically to explore Venus. The thick atmosphere presented a unique challenge, as traditional imaging methods could not penetrate the dense cloud cover. Nevertheless, the Soviets achieved several historic milestones. Venera 4, launched in 1967, became the first spacecraft to successfully enter and transmit data from the atmosphere of another planet, revealing its chemical composition. Subsequent missions, such as Venera 7 in 1970, marked another breakthrough when it became the first spacecraft to land on Venus and transmit data from its surface, albeit briefly. These missions provided critical insights into the planet's crushing atmospheric pressure, which is over 90 times that of Earth, and the corrosive nature of its clouds. In the decades that followed, both the Soviet Union and NASA continued to refine their methods of studying Venus. Radar imaging, pioneered by missions like NASA's Magellan spacecraft in the early 1990s, allowed scientists to map Venus's surface in remarkable detail, despite the planet's opaque clouds. These maps revealed a landscape dominated by volcanic plains, vast plateaus, and unique geological features such as coronas and pancake domes. Venus remains an enigmatic world with many questions still unanswered, including whether it once harbored oceans or conditions suitable for life. Recent discoveries of potential biosignatures in its atmosphere have reignited interest in exploring this fiery neighbor. The lessons learned from past missions underscore humanity's determination to uncover the mysteries of our solar system, no matter how challenging the journey may be. The Soviet Union's Venera program was the first to achieve the monumental task of landing probes on Venus and transmitting images back to Earth. These missions marked a significant milestone in planetary exploration. Venera 7 in 1970 was the first spacecraft to land successfully on another planet. Venera 7 transmitted data from the surface of Venus for 23 minutes before succumbing to the extreme conditions. While it did not carry cameras, it paved the way for future missions, including Venera 9 and 10 in 1975. These missions became the first to capture black and white images of Venus's surface. The images revealed a desolate, rocky landscape with sharp-edged stones scattered across the ground. The surface appeared to be made of basaltic rock, suggesting volcanic activity. Venera 13 and 14 in 1982 provided the first color images of Venus's surface. The photos depicted a reddish-orange landscape bathed in dim, diffused sunlight due to the thick atmosphere. The surface was littered with flat, fractured rocks and evidence of volcanic plains. Venera 13 also recorded the first audio from another planet, capturing the sound of Venus's harsh winds. The Venera images painted a picture of an alien world where temperatures could melt lead, and atmospheric pressure was equivalent to being 900 meters, 3,000 feet, underwater on Earth. Despite these harsh conditions, the Soviet landers operated for over an hour, far exceeding expectations. Given the difficulty of capturing optical images through Venus's thick atmosphere, scientists turned to radar imaging to map the planet's surface. Radar can penetrate clouds and provide detailed topographic data. NASA's Pioneer Venus Orbiter, launched in 1978, used radar to create the first global map of Venus's surface. The data revealed vast plains, highland regions, and what appeared to be volcanic structures. NASA's Magellan spacecraft, launched in 1989, revolutionized our understanding of Venus by using synthetic aperture radar to map 98% of its surface with high resolution. The radar images revealed a world dominated by volcanic activity, with massive lava flows, calderas, and pancake-like domes formed by viscous lava. Magellan also identified a lack of tectonic plate activity, suggesting that Venus's crust behaves differently from Earth's. The radar images from Magellan showed that Venus is a planet shaped by intense volcanic activity and periodic resurfacing events. These findings hinted at a dynamic geological history, with the planet's surface being periodically repaved by volcanic eruptions. The real images and radar data from Venus have provided a detailed, if surreal, picture of the planet's surface. Here are some of the key features observed. Volcanic plains. Most of Venus's surface is covered by vast plains formed by ancient lava flows. These plains are relatively smooth but punctuated by volcanic features such as shield volcanoes and lava domes. Highlands and mountain ranges. Venus has two major highland regions, Ishtar and Aphrodite Terra. Ishtar is home to Maxwell Montes, the highest mountain range on Venus, which rises about 11 kilometers, 7 miles, above the surrounding plains. Impact craters are relatively rare on Venus, as the planet's surface is geologically young, with an estimated age of 360 million years. The thick atmosphere also prevents smaller meteoroids from reaching the surface. Coronas and tesserae. Unique to Venus, coronas are large circular features thought to form from upwelling magma. Tesserae are highly deformed regions of the surface with a complex tiled appearance, likely caused by intense geological stress. Color and light. The real color images captured by the Venera landers show a reddish-orange surface, likely due to the scattering of sunlight through the sulfuric acid clouds. The lighting is dim and diffuse, creating an eerie, otherworldly ambience. Venus's atmosphere plays a significant role in shaping its surface appearance. The dense carbon dioxide atmosphere creates a runaway greenhouse effect, trapping heat and leading to the planet's extreme surface temperatures. The sulfuric acid clouds not only obscure the surface but also contribute to the chemical weathering of the rocks. The atmospheric pressure on Venus is about 92 times that of Earth at sea level, equivalent to the pressure found nearly a kilometer underwater. This immense pressure compresses the rocks and alters their physical properties, contributing to the planet's unique geology. In recent years, interest in Venus has resurged, with several missions planned to revisit the planet and uncover its remaining mysteries. NASA's Veritas, Venus emissivity radioscience, interferometry, topography, and spectroscopy, scheduled for launch in the late 2020s, aims to map Venus's surface in high detail and study its geology. NASA's Da Vinci Plus, Deep Atmosphere Venus Investigation of Noble Gases, Chemistry and Imaging mission will focus on Venus's atmosphere and is expected to capture high-resolution images during its descent to the surface. ESA's Envision, the European Space Agency's mission, will complement NASA's efforts by studying Venus's surface and subsurface with radar and spectroscopy. These missions will build on the foundation laid by the Venera and Magellan missions, providing new insights into Venus's geology, atmosphere, and potential for past habitability. The real images from Venus captured by the Venera missions and radar imaging have given us a tantalizing glimpse of an alien world. Venus's surface, shaped by intense volcanic activity and extreme atmospheric conditions, is both hostile and fascinating. Despite the challenges of exploring such an inhospitable environment, our efforts have revealed a planet that is both similar to and profoundly different from Earth. As we prepare for the next wave of Venus exploration, the images and data from past missions serve as a reminder of humanity's ability to overcome immense challenges in the pursuit of knowledge. What lies beneath the clouds of Venus remains one of the greatest enigmas of our solar system, and future missions promise to bring us closer to unraveling its secrets. Venus, often referred to as Earth's evil twin, presents a stark contrast to our home planet despite their similarities in size, mass, and proximity to the Sun. Its extreme conditions have long made it a target of scientific study, yet these very conditions have posed significant challenges for exploration. Beyond its inhospitable surface, Venus's atmosphere itself presents a series of mysteries. Comprised mostly of carbon dioxide, with clouds of sulfuric acid, it exerts a crushing pressure that would immediately flatten any spacecraft attempting to land without proper shielding. The atmosphere's temperature, a result of the intense greenhouse effect, consistently remains hot enough to melt lead, making the surface of Venus one of the most extreme environments in the solar system. The thick cloud cover of Venus, which perpetually shrouds the planet from view, is one of its most defining characteristics. These clouds are not only dense and toxic, but they also obscure our ability to observe the surface directly using visible light. This has forced scientists to turn to other methods, such as radar imaging, to gain a better understanding of Venus's surface and topography. Even in the 21st century, radar remains one of the most effective tools for studying Venus. Technologies like synthetic aperture radar, which is capable of sending signals through the thick atmosphere, allow scientists to create detailed maps of the planet's surface, revealing volcanic landscapes, mountain ranges, and possible signs of past tectonic activity. One of the significant discoveries made through radar mapping is the detection of Venus's vast volcanic plains. These regions are marked by expansive lava flows and large, circular structures known as coronae. It is believed that these coronae are formed by upwelling hot material beneath the planet's surface, which then creates cracks and deformations in the outer crust. This suggests that Venus may still be geologically active today, though its volcanic activity differs from Earth's in significant ways. Venus's lack of plate tectonics means that the planet's surface is not subject to the same geological processes that we observe on Earth, such as continental drift and subduction zones. Instead, Venus's surface is periodically resurfaced by volcanic events, erasing evidence of previous geological activity. While the surface of Venus remains difficult to explore directly, advances in atmospheric science have provided valuable insights into the planet's dynamic and hostile atmosphere. Venus's thick, sulfuric acid clouds are constantly buffeted by superrotating winds, which move at speeds much faster than the planet's rotation. These winds, which can reach up to 360 kilometers per hour, 224 miles per hour, play a crucial role in the planet's weather systems, helping to redistribute heat across the surface and further intensify the already extreme temperatures. The atmosphere also contains traces of chemicals such as phosphine, which has led some scientists to speculate about the possibility of life in Venus's upper atmosphere, where conditions are more temperate compared to the searing surface. The discovery of potential biosignatures, including phosphine, has sparked renewed interest in Venus. While there is no evidence yet to suggest that life exists on the planet, this finding has opened new avenues for exploration, including the possibility of life forms existing in the more temperate regions of the atmosphere. Some researchers hypothesize that these life forms could exist in the upper cloud layers, where the temperature and pressure conditions are more favorable than on the surface. To explore this possibility, future missions may need to focus on studying the composition of Venus's atmosphere in more detail, looking for signs of organic compounds or other markers of life. In addition to its potential for biological exploration, Venus is also considered an important planet in the study of planetary climate systems. Understanding the mechanisms that drive Venus's runaway greenhouse effect may provide crucial insights into how climate change could impact Earth. Venus's climate history, as well as its ongoing atmospheric processes, offer a unique natural laboratory for scientists to study extreme greenhouse conditions and gain a deeper understanding of planetary habitability. By studying Venus, scientists hope to unravel the complexities of planetary climates and learn how such systems evolve over time. As we look to the future of Venus exploration, a new generation of missions is on the horizon. Upcoming missions like NASA's Veritas and ESA's Envision are set to further expand our understanding of Venus's geology, atmosphere, and potential for past habitability. These missions will build on the successes of earlier probes and telescopic observations, using state-of-the-art technology to provide new, detailed images and data from the surface and atmosphere of Venus. These next missions may also explore whether Venus could have once had a more Earth-like climate, with liquid water on its surface, before transitioning to its current hostile state. Such studies could provide critical insights into the evolution of terrestrial planets and offer a deeper understanding of our own planet's future in an ever-changing solar system. The mysteries of Venus, from its extreme surface conditions to its enigmatic atmosphere, continue to intrigue scientists and space enthusiasts alike. While it remains an unforgiving world, it also holds the potential for remarkable discoveries. As technology continues to advance, our ability to peer deeper into Venus's secrets will only improve, bringing us one step closer to solving the puzzle of this fascinating and challenging planet.